Welcome back to Pep Talk with David. Today we're looking at TB-500, another one of the most commonly discussed peptides in athletic recovery and injury rehabilitation circles. I feel like I'm saying that about every single peptide, but that is the nature of the peptide conversation today. To understand TB-500, we need to start with where it comes from. Yet again, a naturally occurring protein called Thymosin Beta-4. What is Thymosin Beta-4? Thymosin Beta-4, abbreviated TB4, is a naturally occurring protein found in almost all human cells. It's one of the most abundant proteins inside of cells, and it plays a critical role in the organization of the cytoskeleton, which is the internal scaffolding of the cell. Specifically, it binds to a molecule called G-actin, which is the building block of actin filaments. Actin, if you're not aware, like I wasn't, is essential to cell movement, cell division, and critical for our purposes here today, tissue repair. Okay? Thymosin Beta-4 was first isolated from the thymus gland, which is where it gets its name, though it is produced all throughout the body. Research published in journals, including the Annals of the New York Academy of Sciences, the FASB Journal, and the American Journal of Pathology, has examined TB4's role in wound healing, cardiac repair, and regeneration of blood vessels. What is TB-500 and how does it relate? TB-500 is a synthetic peptide that corresponds to the specific region of the thymosis beta-4 protein, approximately amino acids 17 through 23. This fragment is believed to be the active portion of TB4 that's responsible for healing and anti-inflammatory effects. TB-500 was developed partly because the full TB4 protein is large and more complex to synthesize, and so the shorter fragment is more practical for research use. Much like BPC-157, which I discussed in our last episode, I want to note that this also is one that I have researched even more extensively than the other peptides that we will discuss. It's important to note that TB-500 is not FDA approved for any indication. It's not the same thing as a pharmaceutical product containing thymosis beta-4, though some pharmaceutical grade TB4 preparations have been studied in clinical trials. What does the research say about TB4 and TB-500? Preclinical research, again, primarily in animal models, similar to BPC-157, has examined several areas. As I mentioned, in cardiac research, studies have looked at TB4's availability to protect heart muscle after injury and to promote new blood vessel formation. Okay. Research published in Nature found that TB4 can stimulate the differentiation of certain progenitor cells in the heart, suggesting potential regenerative effects after myocardial infarction. However, translating this to clinical use in humans is still in early investigation. In wound healing, TB4 has shown acceleration of tissue repair in animal models of skin wounds, muscle injuries, and corneal damage. Some of the research has progressed to human trials for wound care applications with mixed but generally encouraging results in these small studies. In neurological contexts, animal research has examined TB4 in traumatic brain injury and stroke models, suggesting some neuroprotective and repair-promoting effects. But again, as is often the case, human data is limited. But that does not invalidate the data that is there or the research effects that are being discussed. What about the specific TB-500 fragment in athletes in particular, since this is a wound care peptide? What about in athletes? Well, this is where we move further from the established science and closer to the community use. But again, I am someone who wants to make clear that community use and research does not invalidate what we are seeing out there. No, this is precisely why peptides are being talked about so much, because there are large groups of individuals researching these things and seemingly receiving much of the benefits that we have observed in animal models. The use of TB-500 by athletes for injury recovery, muscle strains, tendon issues, joint problems is widespread in certain circles. The proposed mechanism is that by activating actin-related pathways, TB-500 accelerates the soft tissue repair and reduces their recovery time. Okay? Without large randomized control human trials on TB-500 as a standalone compound, much of what circulates is preclinical, case reports, or anecdotal. And the World Anti-Doping Agency prohibits Thymosin Beta-4 and its fragments, including TB-500, in competitive sports. I did not research, but it would be interesting to see what its effect in athletes over in the enhanced games has been, and what those athletes are saying about TB-500. So it's not a statement about efficacy, but about the agency's position on peptides with potential performance-enhancing implications. Let's go over safety considerations with TB-500. In animal studies, TB4 and TB-500 have generally shown low toxicity, which is a good thing. There are no widely reported severe adverse events in the preclinical literature, and one of the people that I follow most closely has said that even in his practice, he has not observed anything that would be severe. However, and as with BPC 157, the angiogenic properties of TB-500 raise theoretical concern about potential effects on tumor growth. Okay, this keeps coming up. It's not been demonstrated in humans, but it is a consideration that cancer survivors or individuals with cancer risk factors should raise with their physician. Additionally, the same quality and purity concerns that apply to gray market BPC 157 and other research-only chemicals apply equally to TB-500 sold as a research chemical. So let's compare BPC 157 and TB-500. Frequently, these two peptides are discussed together, and for good reason. Both are aimed at recovery and tissue repair. And some protocols do combine them. You've probably heard out there floating around on TikTok or Instagram, the glow stack or the clo stack, okay? When stacked together, often the glow stack contains both BPC 157 and TB-500. But they work through different mechanisms. BPC 157 appears to work primarily through growth hormone receptor upregulation and nitric oxide pathways, while TB-500 works through actin regulation and cell migration pathways. Whether there's synergy between them is a question that's been raised in preclinical research, but it's not been evaluated in human studies. So, how do we summarize this today for regular people? Well, Thymosin Beta-4 is a real, naturally occurring protein with a meaningful body of research behind it, particularly in cardiovascular and wound healing contexts. TB-500 is a synthetic fragment of that protein, and the preclinical data is very interesting. Human clinical trial evidence, while limited, is interesting because the anecdotal research through athletes and other recovery use is widespread, but not clinically validated. And as always, the quality of available products is a major concern outside of clinical settings. One of the things that is encouraging to me is that with some of the recent government adjustments in peptides, we will continue to see more 503A compounding labs which are scrutinized and regulated, producing these, which should result in increased safety around these peptides such as TB-500. Next episode, we're moving to growth hormone secretagogues, specifically ipamorelin, one of the most commonly discussed peptides in the anti-aging and longevity space. Okay, Mr. Brian Johnson. So talk to your doctor, stay curious, and come back next time for another Pep Talk with David.